Okay. Hello. We're going to do chapter 2. We're starting on chapter 2, which is descriptive statistics. Okay, so this first section, we're actually going to cover all of these sections. 2.1 and 2.2 are essentially about frequency distributions and important graphs. So, important graphs. And then in class, we'll talk about 2.3,
It's 15 hours.
2.3, 2.4, and 2.5. So 2.3, which is measures of the center. So measuring the center of data. And then variation and position. All right. So for 2.1, frequency distributions and their graphs, let's get started. We've got our list of objectives. We're going to learn how to construct a frequency distribution. Part of the frequency distribution, constructing a frequency distribution, is knowing the definition of all of these things. So limits, you need your limits, your upper limit, your lower limit of your class, your midpoint, class midpoints, relative frequencies, cumulative frequencies, and boundaries. You're also going to find out about class width. So that's another thing to put on here. Class width. Okay, and then the second part will focus on how to draw the graphs. So this is dealing with the table or chart, and then these are dealing with graphs. Okay, all right. So the first thing is a frequency distribution is essentially a table, and the table has two pieces of information. So it gives you, for each class, it gives you a frequency. Notice that F is the notation for frequency. And yeah, that's here down here. So this little F throughout the entire book will stand for the frequency, okay, which is just a count. So it's the number that you have, right? So it's so let's start here. So a class, a table that shows classes or intervals of data with a count of numbers of the number of entries in each class. So when we are forming our frequency distribution, when we're constructing a frequency distribution, we're going to have essentially three things to do. So the first 1, 2, 3, 1, 2, and 3 involves setting up the classes. So steps 1 through 3, you're setting up the class, setting up the classes. Classes are essentially groups, right? So classes are intervals, that's another word for it. And then steps 4 and 5, you're setting up the frequencies. Okay. So first you're going to decide on the number of classes, usually between 5 and 20. Pretty much we're going to be, problems in the textbook, problems on the exam, it will be stated in the problem, the number of classes, right? So when it says here to decide on the number of classes, really, this is more speaking practically in real life, so not so much in the classroom setting. And the reason why you don't want to have less than 5 is because if you have too few groups, right? So think of a class as a group. If you only have split your data into 2 groups, it's going to be hard to notice patterns, or 3 or 4 groups, or 1 group. There's no point to having 1 group, right? Because you're not able to notice any trends or any patterns. And if you have a lot of groups, like over 20, so if you have over 20 classes, then it also is very difficult to find any patterns because you're going to have several classes probably that don't have any data points in them. So a good number in general is any number between 5 and 20. Okay? And it's not a hard and fast rule, it's more just guidelines. Okay. So first thing is to remember steps 1 through 3. What we're focusing on is setting up the classes. So you're going to determine the number of classes you need. Then you're going to find the class width. Now, class width. Class width. There's actually a formula for class width, and here's how you get it. In order to figure out the class width, you're going to determine the range of the data. Now, when we say the range, we mean that numerical value, which is the max minus the min. Okay. Then you're going to divide the range by the number of classes. So you're going to have your max minus min over your number of classes, right? So this is your range over your number of classes. And then you're going to round it up to the next convenient number. So it might be that a convenient number is the next integer. It might be that it's a decimal. It depends on the data set that you're working with. Okay, once you've found the class width, now it's time to set your class limits. So you've got upper limits and lower limits. I want to look back. I'm going to show you back here. In this list here, the upper limits, I'm going to highlight them in a green color. So for your upper limits, 5 is an upper limit, 10, 15, 20, 25, 30. These are all upper limits. And then I'm going to do the lower limits in this sort of grayish color. Lower limits, 1, 6, 11, 16, 21, 26. Okay, so you can see that the class width, right, is the difference between any two consecutive lower class limits. So 6 minus 1, that's 5, right? 11 minus 6, that's also 5. 16 minus 11, that's also 5. 26 minus 21, that's also 5, right? And it's also the difference between upper class limits. What's 10 minus 5? 5. 15 minus 10, 5. So your difference from here to here is going to be 5. From there, 5, 5, 5, 5. And this distance here. So notice that the class width is telling you how wide the class is. And the class width is, it has to be the same. So the width has to be the same for each class. Okay? So once you've found your class width, you're going to use that to find your class limits. And you've got upper limits and lower limits. So you start off with your minimum. So you start with your min data entry as the lower limit of the first class. And then you're going to find the rest of the lower limits. And then you find the rest of the upper limits. And so after you do 1 through 3, we are now on steps 4 to 5. We're now on steps 4 to 5, which is setting up your frequency. And so to set up your frequency, you're basically going to mark it. You're going to make a tally mark for each data entry in the row of the appropriate class, and then you're going to count the tally marks to find your total frequency. And remember, that's what this symbol F stands for. Okay, so let's do this example here, constructing a frequency distribution. So we've got a data set here. First thing, let's look, what is N? So N is equal to the total number of data entries. That's equal to, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 20, 30. So we have a total of 30 different numbers here. And each of these, oh, look, we didn't even need to do that because it says here the following sample lists the prices in dollars of 30 portable GPS navigators, right? So how much does your GPS navigators cost? You can buy them online. Maybe you have them on your cell phone, right? So looking at this data, let's see if we can tell already what is the min, because we're going to need the min and we're going to need the max. So for the min, it looks like the min is 59. So that looks like the min. So let's write that down for the min. And for the max, let's see, it looks like 450 is the max. So what this is saying is that for this sample of 30 GPS, the price of 30 different GPS navigators, The cheapest one was $59, and the most expensive GPS navigator was $450. Okay. So what we're going to do is we're going to construct a frequency distribution for this data set. Okay. So let's look back at our instructions here. So what we'll need to do for the first thing is to decide on the number of classes. So how do we decide the number of classes? Well, in this case, it's given to us in the problem because it says we need to construct a frequency distribution that has 7 classes. So our number of classes should be 7. So that's step 1. So let's just put here number of classes equals 7. Okay. Now, the second step is to find the class width. So to find the class width, remember, we need the range. So we need range over number of classes. That's the first thing we do. Now our range is going to be max minus min over number of classes. Now we said our max was 450 and our min was 59. So 450 minus 59 divided by 7. And what do we have? So 450 minus 59 divided by 7. That'll give us 450 divided by 59. No, 450 minus 59 should give us, let's see. Let me get my calculator. So I need 450, delete. Okay, I can't turn on my calculator. Let's see. Okay, 450 minus 59, 391, divided by 7. So if we need 391 divided by 7, okay, that is 55.85714 ... And because our data set is a bunch of whole numbers, we're going to round this to just 56. So we're going to round this to a whole number because our data set consists of entry points that are whole numbers. If we had a data set with like 0.1, 0.2, 0.03, 0.1, 0.7, 0.6, decimals like that, then we would probably round this number to a decimal. But for our case, it's appropriate to have as our class width 56. Okay, so this is going to be our class width. And we know our number of classes is equal to 7. So the next part we want to do is we want to find our class limits. So here's how we're finding our class limits. So 2, 3, 4, 1, 2, 3, 4, 5, 7. Okay. So you're going to have, we'll start with our lower limits, and then we'll start with our upper limits. And then we'll finish with our upper limits. So for your lower limit, the first number you want to put in is your min, which is 59. So we're going to put in here 59 for our lower limit. Now, we're going to fill in this number right here. To get this number, we're going to add 56, because 56 is our class width. So you add your class width. So 56 plus 59 is 6, plus 59, 115. Okay, and now to get the next number, I'm going to add my class limit again. So I have 115 plus 59, 174. Okay, and then I'm going to add plus 56. 174 plus 56. Wait, I think I made a mistake. So let's try this again. So I start off with your min.
15.
Start off with your min. Add 56. So 56 plus 59 is 115. 115 plus 56 is 171. Okay, 171 plus 56 is 227. Plus 56, 283. Plus 56, 339. Plus 56, 395. Okay, so these are my lower limits. Now, to get my upper limits, pretty easy. I'm going to subtract 1. So the 115 is going to go to 114. Okay, 171 is going to go to 170. 226, 282, 338, 394. And now to get this last one here, I'm going to add 56. So 394 plus 56, 450. Okay, all right. So we now have our classes. So we have our 7 classes. And what are our 7 classes? They are 59 to 114. That's our first class. 115 to 170. 171 to 226. 227 to 282. 283 to 338. 339 to 394, 395 to 450. Those are our classes. So we've got the first half of our frequency chart done. Now the second half, of course, is going to be to come up with the tallies. So let's go ahead and prepare to do that. Okay. So we're now on the fourth one. And the fourth step is to make a tally mark. So let's paste. All right, so here's what we'll do. So we're going to do our tally marks. And in order to do the tally marks, I'm looking back at the data that I have. And the data, so see how this 90, so 90, I'm going to cross out 90 and I go here and I put a tally mark in this class since 90 is in between 59 and 114. Okay, what's my second one? Is 130. And 130 is here. The third data point is let's see, what's the third data point? Third data point is 400. So 400 goes here. 200 goes here. 350 goes here. 70 goes here. 325 goes here. 250. 275. Can you call it out to me? I'm starting at 270.
270.
270?
Yes, okay. 270. Then 150.
150.
130.
130.
59.
59.
200.
200,
160,
160,
450,
450,
300,
300,
130,
130. Okay, so for 130, I'm just going to mark it off like that.
220,
220,
100,
100,
200,
200,
400,
400,
200,
200,
250,
250,
95,
95,
180,
180,
170,
170,
and the last one is 150.
150. 150. Okay. So you can see why it's important for the classes to not overlap. So classes cannot overlap. And also there needs to be the classes, every number should fit in a class. So there can't be big gaps. So no big gaps between classes, because then you might have a data entry that doesn't fit in a particular class. Every data entry must fit in a class. Okay, so that's basically the key point there. And our last step, so we'll say this is 4 and 5. Our last step is to tally, is to add up the tallies and actually have our frequency. So this little F symbol stands for frequency. So this is going to be a 5. This is going to be a 7. This is going to be a 6. This is going to be 4. The frequency of this class is 2. The frequency of this class is 1. The frequency of this class is 3. Okay. So notice that the sum of the frequencies is equal to n. So if you add up all these numbers, right, so what does this sigma mean? This sigma, so sigma means add up, right, so if you add up all the f's, it should be equal to n. What happens if we add them up? We get 5 plus 7 plus 6 plus 4 plus 2 plus 1 plus 3. 28. Uh-oh, we made a mistake. We got to go back and fix it, right? So wait, 5 plus 7 is 12, plus 6 is 18, plus 4, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Made a mistake. Got to do it again.
Okay.
All right. This is real life, people. All right. So we've got to go back and do our tallies. Again, because we left off some numbers, and if we don't have all of our data, then our frequency distribution is won't be accurate. Okay, so let's call out the numbers again.
90,
90, got it.
130,
130, got it.
400,
400,
200,
200,
350,
350,
70,
70,
325,
325,
250,
250,
150,
150,
250,
250. Let me see. 250,
275,
275,
270,
270,
150,
150,
130,
130,
59,
59,
200,
200,
160,
160,
450,
450,
300,
300,
130,
130,
220,
220,
100,
100,
200,
200,
400,
400,
200,
another 200, got it.
250,
250, got it.
95,
95, got it.
180,
180,
mhm,
got it.
170,
170, got it.
150,
150, Got it. All right, so let's do our F's, our frequencies. So that'll be 5, 8, 6, 5, 2, 1, 3. And what is the sum of F? 30. All right, so where did we, that was wrong. That should have been an 8. Our second class was off, and then 6, and our fourth class was off. That should have been a 5. Okay, and now we'll get 30. Good job. All right. Okay, so you can kind of get an idea of why I like to emphasize using technology, because it's a lot easier to go back and make and correct your mistakes if you find your errors, if you have errors. So you'll notice in this course I will not be doing too much stuff by just pencil and paper. The reason why I wanted to do this was to give us a good solid foundation for constructing these frequency distributions. But in general, if we can do it on a computer easily or a calculator, we will do that. All right, so we've got our frequency distribution, and I believe that's it. So the next thing here is determining the midpoint. So determining the midpoint of a class. And what I'm going to do is I'm going to determine the midpoint, I'm going to actually, let's see here. Paste. Remember, these were our classes. These were the classes. So we could write down, let me see, it'd be lovely if I could make this smaller. But I don't think I can. I think it's just a raw cut and paste. We can go ahead and find the formula for the midpoint. So if we write the midpoint of the class, here's how we do it. You take your upper, so we've got this formula. Make sure you know this formula. The midpoint of a class is the lower plus the upper divided by 2. Okay? That's probably not that appealing visibly. So let me just say, here's the formula you need. Is that the midpoint is the lower limit plus the upper limit divided by 2. So for instance here, we would take 59 plus 114 and divide by 2. And you see that's what they've done here. They got 86.5. So you can find the midpoints of each class, right? So 115 plus 170 divided by 2, that gives you 142.5. You can do that all the way down. Notice that the difference between the class widths is equal to, the distance between the midpoints is equal to the class widths. So the distance, the distance here, the difference, this difference is the class width. This difference here is the class width. And this difference here between the midpoints, class width. So the difference between the lower limits of any 2 consecutive classes is the class width. The distance between the upper limits of any 2 consecutive classes is the class width. And the distance between the midpoint of any 2 consecutive classes is the class width. Okay? Now let's see here. So we can determine the relative frequency. We've got another formula. Relative frequency of a class is going to be the class frequency divided by the sample size. Okay, so you can look here, and for each class, you can calculate the relative frequency. So remember how we had our frequency was 5? Well, our relative frequency is going to be 5 over 30. For here, the frequency is 8. Relative frequency is going to be 8 over 30. Because remember, for us, so for this data set, n is equal to 30. Okay, so each time you're dividing by 30. And the last thing is the cumulative frequency. So cumulative, remember how you can have a cumulative GPA? And a cumulative GPA doesn't take into account just your GPA, your scores from last semester, but it takes into account your grades for all of the grades you've ever had up until that point. It's the same thing with the cumulative frequency. So to get the cumulative frequency, you are literally just going to add all of the frequencies up until that point. So the cumulative, the cumulative frequency for this class right here, for the second class, is going to be 5 plus 8, which gives you 13. Okay, and then to get the cumulative frequency for the next class, you take 5 plus 8 plus 6, which is going to be 19. Okay, so the cumulative frequency of a class is the sum of the frequency for that class and all previous classes. And we can form here, now that you've got your midpoint, so once you've got your midpoint, your relative frequency, and your cumulative frequency, this chart is now called your expanded, 1530. Thank you. Your expanded frequency distribution. Now, just in general, if you just have this beginning part right here, that is just your frequency distribution. But once you add all of this information, it is your expanded frequency distribution. And please note that, as we said before, the sum of your frequencies is n. So let me highlight this. So the sum of your frequencies is equal to n. So this is always. The sum of your frequencies is equal to n. The sum of your relative frequencies is equal to 1. So the sum of your relative frequencies is equal to 1. And the last cumulative frequency, the cumulative frequency of your last class, is always equal to n. Okay? So those are some patterns to notice. So for our next part, we're going to talk about graphs of frequency distributions. Here's where we'll actually use the midpoint more. So we're going to have, notice that for a frequency histogram, anytime you have a histogram, your horizontal scale has to be quantitative. Okay? So we'll have a quantitative values on our horizontal scale, and always frequency is on your Y scale. Okay? And then lastly here, consecutive bars must touch. And a frequency histogram is a bar graph that represents the frequency distribution. So let's do an example. And in order to figure out how to do the, wait, I'm missing a slide. I am missing a slide. In order to figure out, oh no, it's coming later on. Okay. So in order to do a frequency histogram, you've got two basic ways you can do a frequency histogram. Let's just fast forward to this example. Right, so suppose we had an example where we want to construct a frequency histogram. Now we already have our class and we already calculate our, suppose you calculate your class boundaries. So we'll talk about class boundaries in a little bit. You can form your histogram using midpoints or using class boundaries. So we already know about midpoints. So let's look at how to do the frequency histogram using midpoints first. The midpoint of each class is the center of your histogram bar. Okay? So you see your center of your histogram bar here is a midpoint. And how high the bar is depends on the frequency of that class. So you get an idea here. So the second class had a midpoint of 142.5 and it's got a height of 8. So the midpoint was 142.5 and it has a height of 8. Notice that, remember how we said that the distance, we said that between from here to here is 56 and between here and here is 56. The class width is the distance. Remember how we said that? That means that the size of our rectangles are going to all have the same width. So the class width corresponds to the width of the rectangle. So let's write that down. Class width corresponds to the width of the rectangle in the histogram. So that's why in the histograms. Okay. And so that's why it's important that your class width be constant. Okay, we're going to need that. We'll put that. Let's put that here. We'll put that note here as well. Okay, so now let's talk about the second way to construct a frequency histogram, and this is using class boundaries. Now, class boundaries are pretty simple to calculate. Pretty much what you're going to do for your class boundary is you're going to look at, now remember these are lower limits, right? So if you have your lower limits, lower limit, subtract 0.5, and that's how you get your lower boundary. So 171 minus 0.5 gives you 170.5, right? So you subtract 0.5 to get your lower boundaries, and then for your upper limits, you add 0.5 to get your upper boundaries. So see how we're adding 0.5 to get our upper boundary here? 170 is going to go to 170.5, right? 226 is going to go to 226.5. So you got your lower limit, your upper limits, your lower boundaries and your upper boundaries, and your midpoints. Okay? And now, if you're using class boundaries, what you're going to do is instead of marking the midpoint, you're going to use your lower and your upper boundary. So 58.5 and 114.5, those are your upper and lower boundaries for your first class, right? 58.5 and 115.5. So those are the limits for, you use the boundaries as the limits for your rectangles, okay? And then according to this, you can see that more than half of the GPS navigators are priced below $226.50. So let's look at that. What would that mean? How do we know that? So if we look here, now, which GPS navigators are priced below $226.50? Anything in here, right? So these are priced below $226.50, and these are priced above, right? So if we wanted to see how many of the GPS navigators are priced below, so let's add it up. So we'd have 6 plus 8 plus 5, 6 plus 8 plus 5, which is 19, and that is definitely more than half, because all of the 30 is equal to the total number of GPS navigators, right? So 30 is equal to total. So definitely 19 is more than half of the navigators. And also, if you look at the area of the rectangles, these rectangles, there's more area here than if you compare it to, if you add up this area here, right? So if we add up these rectangles, the green rectangles don't have nearly as much area as the purple rectangles. All right. So the next thing we want to learn is how to graph a frequency polygon. Okay, and it's a line graph that emphasizes the continuous change in frequencies. So our goal here is to construct a frequency polygon for the GPS navigator's frequency distribution. Now, in order to construct our frequency polygon, we're going to need this information. So you need to know your class. From your class, you're going to get your midpoint and then your frequency. So in order to do this, we start off. I'm going to draw my horizontal axis and my vertical axis, and I can draw a little broken line here. Okay. All right. So I start off by plotting my midpoints. So how many midpoints am I going to have? 1, 2, 3, 4, 5, 6, 7. Because again, we have 7 classes. Okay, so I've got 7 midpoints. So I start off by doing my midpoints. 1, 2, 3, 4, 5, 6, 7. 86.5, 114. So let's go ahead and put those in. So this is going to be 86.5, 114, or sorry, 142.5, 198.5, 254.5, 310.5, 366.5, 422.5. Now I'm going to add one more to the left and the right endpoints. To get this last value here, what I'm going to do is I'm going to add 56. So I'm going to add 56 to get this last endpoint. And what is 422.5 plus 56? So that should be 478.5. Okay, and now if I subtract 56, what is 86.5 minus 56? So that should be 30.5. Okay, now I'm ready to put in my axis here, my vertical axis. So let's see here. So this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm doing that because, look, my highest frequency is 8 and my lowest frequency is 1. So if I go from 0 to 10, I should be good. So this is 10, 1, 2, 3, 4, 5, 5. Now, these small endpoints, I'm going to make that a 0. The left and the right endpoints are always going to be 0. Now just plug in my frequencies. So the midpoint 86.5 corresponds to a frequency of 5. So I'm going to plot that point. And then the next class has a frequency of 8. So I go up to 6, 7, 8. So this one's going to go up to 8. And then down to 6. And then down to 5 again. Back down to 5. And then down to 2. And then down to 1. And then up to 3. And then back down to 0. And finally, I'm going to connect with just straight lines. And so this is our polygon. All right. Okay. So the two essential graphs that you need to be able to do are a histogram and a polygon. Okay. Now, once you have a histogram, you can create, once you know how to do a histogram, from there it's easy to create a relative frequency histogram. It's going to be pretty much the same thing. You're going to have down here your data values, and up here, instead of doing your frequency, you're going to graph your relative frequency. So it has the same shape and the same horizontal scale, right? So same horizontal scale. Down here, you're going to have your different classes as the corresponding frequency histogram. But the only change is that for your vertical scale, you're going to measure relative frequencies as opposed to measuring just frequencies, okay? So we've got a picture here. You can look at the data. You're going to be graphing your class. So you still have your class boundaries, but now instead of graphing your frequency, you're going to graph your relative frequency. And the benefit of using relative frequency instead of frequency is that now we have a sense of proportions. So as we see here from the graph, you can see that 20% of GPS navigators are priced between $170.50 and $226.50. So notice here, 20%, that's the same thing as 0.2, right? And so this rectangle here, what this rectangle means is this represents the number, the relative frequency, so it represents the percentage of all of the GPS navigators that are priced in between 170.5 and 226.5, right? And so we can see about 26 or 27% are in between 114 and $170, and you can get a picture of the percentages very quickly just by using
1545.
Just by using the relative frequency histogram. Okay. Similarly, you can do a cumulative frequency graph, Polygon, okay, or Ogive. Okay, so a line graph that displays the cumulative frequency of each class at its upper class boundary. Okay, so that's the key thing here is for here, your vertical axis, your vertical scale is going to be keeping track of the cumulative frequency. For the horizontal scale, you're actually going to use the upper class boundaries, okay? So we're not going to use the midpoint. You're going to use the upper class boundaries. So I'll let you read that, but you can look and see. So we're going to use our upper class boundaries as our horizontal scale. But now we're going to need some place to start off with. So you also throw in that lower boundary of your first class. So see, that lower boundary of your first class, you set it equal to 0. And then for each of your upper boundaries, upper class boundaries, you go ahead and you plot them. This, you should always end up, right? Your last mark here should be your last upper class boundary, and this should be at N. So whatever your N is, that should be the high point of your graph. And now here, notice from the Ogive, you can see that about 25 GPS navigators cost $300 or less. So you can say how many GPS navigators cost less than $300. So let me go down here and look, where's $300? Maybe here's 300. So maybe here's 300. So maybe that's 300. And so I'm going to follow that up. I'm going to say, okay, 25. So all of these, when I add up how many are less than 114, there are 5. How many are less than $170.05? How many are less than that? 13. Why? Because, let's look back at our cumulative frequency. Remember how we got our cumulative frequency was to add it, right? So 5 plus 8 is 13, and then we add 6 and we get 19. So there are 13 that are less than 170.5 because there are 8 that are in this class and 5 that are in this class, right? So you get a total of 13 that are less than or equal to 170. Okay? So you can see how there are benefits, there are pros and cons to each graph. Each graph gives certain information and presents it in a way that is very clear. So from here, it's not very clear how to see percentages, right? But it is clear to give information about overall, less than or equal to $300. That's easy to see, right? So just make sure that you are familiar with how to construct your frequency distributions with your midpoints, your lower and upper limits, your lower and upper boundaries, okay? And then also how to construct an extended distribution, which means you're including not just your class and your frequency, but your midpoint, your relative frequency, and your cumulative frequency. And then, so all of this is about tables, this first part. And then part 2 is make sure that you are familiar and comfortable with your histograms and your polygons. So you've got histograms, which are the bar graphs, and you've got polygons, which are the line, right? So those are the line things. So like there that ends at 0, right? That starts and stops at 0, or something that goes and is always increasing. I don't know why I'm drawing it like that. Right, so this could be a cumulative. This could be an ogive because it's always increasing. And this could be a frequency polygon. Okay, and you've got your histograms, which are your bars. Okay. All right, thank you.